Hi, everyone. Welcome to our first day of remote learning in biology. If you're watching this before, remote learning with the puppy. If you're watching this before our Google Meet, good for you. Thanks for getting a head start on your work. If you're watching this after our Google Meet, thank you for tuning in and hopping on, and it was wonderful to see you. Today we're going to talk about Hardy-Weinberg. Milo is super excited to talk about Hardy-Weinberg and what it means to break down the equilibrium. This is the main piece of math that you guys will do in biology. So I wanted to really make sure that you guys were getting it. I wanted to record myself talking about it, showing you a practice problem so you're good for your assignment. So let's take a look at a problem. This is how almost all of your problems will be written. You will get a part, okay, a number of out of how many individuals that are in the population. So in this one, we have 98 of 200 members of the population express the recessive phenotype. So again, we'll always tell you if it's recessive or dominant. What percent of the population could you predict to be a heterozygote? That's kind of the question that we're going to pop up to today. So if you guys remember from when we took notes on Hardy-Weinberg, this right here is Hardy-Weinberg's equation. P squared plus 2pq plus q squared equals 1. P squared equals your frequency of homozygous dominant alleles, or the percentage of people that are homozygous dominant in the population. 2pq is your frequency of your heterozygotes, and q squared is your frequency of homozygous recessive. There is a secondary equation, though, over here, where we can actually take p plus q, and we should always equal 1, especially if our population is not evolving into sitting in equilibrium, which, again, is relatively rare. So from our first equation, the question that we get is we are looking for our number of our 2pq value, that heterozygote number. So we have to start first by determining how many people in our population are homozygous recessive. That is our q squared value, okay? So q squared. To determine that, we take our part, so 98 divided by 200. All you guys need is a basic calculator. These are the ones I keep in my classroom. So 98 divided by 200, 0.49. You round to 2 decimal places here. 0.49 is our q squared value. Now that we have q squared, we still need to find p in order to find our heterozygote. It's much easier than it's going to sound. Don't clear your calculator, okay? Keep it just like that. First, we have to find p and q to find 2pq. So from q squared, you have to find q. All you do is square root both sides of your equation. So like I said, don't clear it. Here's my square root button. Press it. 0.7. So Q is 0.7, which means 70% of the population carry or show the recessive allele. We take our value for Q and plug it into our equation over here. P plus Q equals 1. P plus 0.7 equals 1. We get P equals 0.3. So now we have 2pq. We have P and we have Q. We're good to go. So we take 2 times 0.7 times 0.3 equals 0.42, or 42% of the population. That's it. That's it. Okay? I do ask that when we're doing Hardy-Weinberg, you show all your work, and I'm going to show you a practice problem on how to show all your work. You can take Hardy-Weinberg a step further. Some questions will ask, is this population in equilibrium? And all you do, plug in all of your values here. So you got your P, you square it, your 2PQ, and your Q squared, or your Q and then you square it. And you do find that this population is in fact in an equilibrium. Let's take a look at a practice problem, and I'm going to do it out for you so you guys can see it. So this question says 538 of 2,000 in the population express the homozygous dominant genotype. Find the frequency of our heterozygote. So we're going to follow those same exact steps, except this time we're going to be looking for p squared to start. So I've already written out the equation just to make it easier. So we have 538 of 2,000 are dominant, so that's p squared. The first thing you want to do is find p squared. Okay, maybe. P squared. Divide your part of your population by the whole. So 538 divided by 2,000 equals, take out our trusty calculator, 538 divided by 2,000 equals 0.269. We do want to round that to 2 decimal places though. So we have 0.27. That's p squared. To find p, you're going to take the square root of p squared. P equals, hit the square root button, 0.52. 0.52. Okay, so then we have our two equations, p squared plus 2pq plus q squared equals 1, and p plus q equals 1. So what we want to do, we need to find q, because remember, we're looking for that 2pq value. That's a really bad p. 2pq. So we take 0.52 plus q equals 1. We get q equals, we take 1 minus 0.52, 0.48. Okay. Finally, we're looking for this. Okay. We're looking for that 2pq value. 2 times p, 0.52, 0.48, close parentheses. 2 times 0.52 times 0.48, 0.499. So let's call it 0.499. Okay, that's it. Okay, that's pretty simple. I really think you guys are going to get the hang of Hardy-Weinberg relatively quickly. You just need a calculator. Sorry for my scribble here on this page, but I will post some practice problems to Classroom for you. So watch this video first before you try doing the homework. Your homework will be due on the next class period. So blue day, your homework is due Friday. White day, your homework is due Monday. And again, if you guys have any questions whatsoever, there's a Google form in Classroom for you to fill out to meet with me one-on-one. And again, if I have already seen you on our Google Meets, thanks for hanging out with us. And if I am going to be seeing you on Google Meets, I can't wait to see you guys. Teaching from home's a little weird for me, but thank you for sticking it out with us. And let me know if you have any questions on Hardy-Weinberg. I am available absolutely whenever you guys have questions. So just let me know if you have questions, and I can't wait to see you guys later.